Hello friends, welcome to the lecture series of operating system. So in today's lecture we will go through a new topic which is called as process control block. So as we have already started with understanding of what exactly is a process, then we have gone through different states like how the processes are actually doing its transition from one state to another state. So this is also one of the important aspects of your process. So when it comes to like a process, so whenever a process is executing in the system, so each process must have a set of instruction, a set of information. So where all these informations are actually being saved, so it is actually saved in a process control block. So every operating system is actually maintaining process control block, or in short we can say PCB. Okay, so every operating system is actually maintaining a separate process control block for each of these processes. So if there are 10 processes that are actually running in the system at a time, so there for those processes there should be 10 process control block or 10 PCBs maintained in the operating system. So let's see what exactly this process control block contains, what are the different sets of information this PCB have. So the first one we have here is the process ID. So whenever any process or the list of process that is actually running in the operating system, so each of those process, we need to uniquely identify those process. Okay, so in order to do that identification, for every process there is a unique identification number set by the operating system, and that is called as the process ID, because we know at some times we need to identify the process. So if there is a list of process, we can easily identify through its unique identifier. So that's why basically we use process ID. It's similar to as like the student ID, through which the student will be identified in a university or in a class, or any like personal identification card like PAN card or driving license. So similarly in operating system also, in order to identify a particular process from the list of several processes, there is a process ID available. Then the next one is process state. So in process state, so as we have gone through the process state diagram, and we know like there are several process states available like new state, ready state, running state, terminate state, then block or waiting state. So a process which is actually is available, or it is in which particular state, so that state information is available in the process state part. For example, if a new process is being created, so it will be in new state. So the process state information for that particular process will be new. Once it is moving from new to ready state, that means it is being uploaded into the, or it has been loaded into the primary memory. So at that time the state will be the state information will be changed to the ready. And next, if it is if it start executing, so that means at that point of time the process state information will be running. Okay, and sometimes if any program, if any other process is trying to access the CPU, or a priority process came into existence, or the same, if the same process is actually requesting for the input output operation, so it need to be removed from the running state and moved to the waiting or block state. So that time also the process information, process state information will change accordingly. So at a particular time the process is in which particular state, so that state information is available here. Next one is program counter. So program counter is nothing but it acts like a pointer. What exactly it does here? Suppose we have a program, and we know in every program we have some lines of code. Suppose these lines of code are available in the set of instructions. Suppose for a particular program we have this instruction I1, I2, I3, I4. Suppose only four instructions were there. Okay, so when the process first starts executing, now the CPU is reading those instructions. Suppose when it start executing, the CPU will read this instruction. So program counter or this particular thing, the pointer is actually pointing to the instruction. That means which exactly it is pointing towards, the next instruction to read. Suppose the first instruction is read, after that the pointer will point toward the next instruction, that is I2. Okay, suppose after first reading of the first instruction and the second instruction, the pointer moved to I3. Okay, so when it moves to I3, immediately like in this, after this instruction, it is actually waiting for some input output operation to happen. Okay, so at that particular time the process moved from the running state to the block state. Okay, so once it moved to the running state to the block state, it actually releases the CPU. Okay, or it is being removed from the CPU. So when this process is moving back to the CPU once again, from wait or block state to the ready state, and from ready state to the running state, the CPU need to resume from where it exactly left. Okay, so for that resume purpose, this program counter is being used. So if this information is being saved in the program counter, okay, this particular pointer, so the CPU will understand, okay, the first two instructions were read, the next instruction to be read is I3 and I4. So the CPU will resume its work from I3 and followed by I4, and finally the process will terminate. Okay, so this is actually used for like saving where exactly the execution is done and what is the next instruction to be executed. Okay, so that information is actually recorded in the program counter. Okay, next one is priority. So in the priority part, we actually keep the information like what is the priority of the process. So we all know like there are several processes that are available in the like operating system. So all these process will come with some sort of priority. For example, the processes which are actually monitoring the system with respect to your malware or any type of error or failure, so those processes are actually comes with high priority. And the process like, okay, playing a music file or watching a video, those are in less priority. So we all know like whenever we are playing a music file, and if any problem is there or any error occurs, so immediately the error message comes up, and in that time it might be possible that that video file will be paused for some time. Okay, so that means the process which is actually triggering that error message is having the high priority. Okay, so in for every process where exactly the priority information will be stored in this particular priority part, like which process comes with what priority, it will be stored in this way. Okay, so this is about the priority part of our PCB. Next one is register. So we all know like whenever we have CPU, so we have some register, that means we have some sort of data stored in the register. So it also helps in what exactly available are information are available in each register, and what exactly till what point the execution of the CPU has been done. For example, some sort of value were calculated at some time. Suppose we have register R1, R2, R3. We have suppose values like 3, 4, 7. Okay, so these registers are having, it acts like some sort of container, and it is having these values. Okay, and after some point of time, suppose any any priority process is trying to access the CPU, that point of time the process will be released. Okay, or the process is actually requesting for any input output operation, so that point of time the process will be removed from the CPU. So where exactly the partially calculated values will be stored in the register. So when the next point of time the CPU will get chance to complete its execution, so actually access these register values and will get these values and finally do its computation and finally terminate. Okay, so it is actually giving the information where exactly or what exactly it is storing in all those like containers or the parameters in the memory. Okay, so this is the information about the register. Next one is file list. So in the file list, we are actually in the PCB, the operating system is actually maintaining the list of file that process is actually trying to access. For example, we may have some sort of process that is accessing some Excel file, or there might be a possibility that one uh, program is actually accessing a text file. So we all have done the file handling program in C. Okay, so when these programs are associated with the file, so that means one or few files are actually the program are actually accessing those files. So if any process is actually dealing with any type of file, so those file lists are actually being maintained in this file list. Okay, next in the next we have input output info. So input output info means we have some sort of input output devices that may be associated with the process. So whatever list of input output devices or the information like the operation that are associated with the process, it will be stored in the input output information. For example, if a process if we have written a C program that accepts two number from the user and displays the value that is being after the addition is being done. So first of all it will ask the user, okay, first of all input the first number, so user will input. Again it will ask for the user to input the second number. So once the once the program got these two numbers, so it will add up and finally displays the result in the monitor. So during its execution, what are the input output devices it used the keyboard, like through keyboard the user will input the two numbers and finally the result will be displayed in the monitor. So input output operation, it is basically using two sort of devices, that is one keyboard and one monitor. If along with that, if we need to print that information in a text file or sorry in a like through a printer, so with that we need to have the list of devices. Like for input output devices, we need to have one keyboard, one monitor and one printer as well. So all sorts of information regarding input output devices or input output operation, it is being stored in the input output info. Finally comes the protection part. So this plays a very important role because we need to have this protection mechanism available in the process control block, because we don't want, whenever any process or whenever a list of processes actually executing in the computing system, so we don't want that one process will go and interfere with another process, so which will actually cause some sort of error in the system. So this protection mechanism will actually take care of all those scenarios, like it should not go and access the memory, that is, suppose one process is accessing some part of memory in the RAM. Okay, so when another process is or suppose the another process is start executing, okay, it should not occupy the RAM that is being stored by the previous process. So all these kind of things are actually being taken care in the protection section. One more example I can give, like if one particular device is actually one particular process is actually using one particular input output device. Okay, so that means that input output device is busy with one particular process. If the second process is also trying to access, so it need to the operating system should allow the second process to wait for some time to access that device. So those kind of things are actually taken care in the protection part. Now the last part, this section is basically contains several information that is dependent upon the like the type of operating system. Okay, so we have Linux based operating system, we have Windows based operating system, we have Macintosh. Okay, so all these different operating system, they have different sets of information, but when we talk about the general information about the process control block, so these many information will be available with respect to the process control block generally. Apart from that, like Windows may have some other sort of information, the Linux based system will have some other sort of information, so those are extra things. But the basic part, or the basic, generally this all this information like must be there in the process control block. Okay, so this is about the process control block. I hope you people have understood. So thank you.